Okay, guys, so what I want to cover is last, I'm just going to do one more example, and I want to look at the energy required to melt plastic. So let's just go from energy and let's just do HD, PE, and we'll go from basically from solid to I don't want to say liquid, but more like a glassy transition. So let's go find the heat capacity for HDPE. Density, heat of combustion, heat capacity, and other thermodynamic properties. Ooh, NIST. Yes, please. My favorite NIST story, I was giving a talk there in 2005, I think it was, and I walked by the Office of Force and Mass. And that's what these guys do. They keep, they are the keepers of the. So let's just see if we can find something here for HDPE. See if they got a table. Investigator. Yes, these guys have put a lot of work into it. We do a Control F for HDPE. This might not even be searchable. Let's just take a look. SAK. No, it's not. Okay. Let's just bang through it here and see if we got molecular weight, heat capacity. Thermodynamic properties of polyethylene. Whoa, guys. All right.
Can we narrow that down?
Well, let's see. What they've got. There's still each one of these are. Well, here's your per grams. Here's your per Kelvin. They're running these at 273. So they're running these at lab conditions, and I think we're seeing here they've got different different ranges, calories per gram, and they've actually got a constant plus 2 times 10 to the negative third. Wow, this is a good one. Did not expect this. Yeah, they even have equations. They even have fifth order equations here saying that the specific heat capacity itself is a function of the temperature, which makes sense. As the temperature changes, so does the heat capacity. Let's see if they've got anything as an average. It's much more we're into. Heat capacities. Okay, so here's millijoules per mole per Kelvin. Let's see if they've got it, millijoules per mole. Gosh, I would much rather have it as a high density polyethylene, joules per mole per Kelvin, crystallinity. Oh, and even with different crystallinities. I am not going to expect you to go into this much detail. Let's just go see if we can find something that's a little easier to read through. Okay, specific heat capacity. There we go. So there's HDPE, specific heat capacity. We're looking at 2,300 joules per kilogram per Kelvin. Okay. And then what we'd also like to look at is the softening temperature. Okay, there we go. So at 120 Fahrenheit, that's what we're looking for. Okay, so I want to figure out how much energy it takes to, and I'll give you the numbers on the exam. I'm not going to ask you to go look these things up and derive a fifth order equation from NIST or anything like that. It's pretty impressive that's there. But I'll give you that the specific heat capacity of HDPE and LDPE is approximately 2,300 joules per kilogram per Kelvin. Let's go ahead and write that down. So C sub P for LDPE equals 2,300 joules per kilogram. Joules per kilogram Kelvin. We can also see that the softening temperature, so this is the temperature at which you could take these materials and remold them. So if you're going to go into a remanufacturing, here's the temperature you need to hit, 50 C. So I'm just going to call that the TS for T soft. And so I'm actually going to I'm going to change this to solid. Oh, and speaking of sunlight, another good problem. We did the solar forge last time. Remember your 100 watts per square meter? I could say, how long do you need to stick your plastic in your solar forge to melt it? We did those calculations on Tuesday for a zinc or copper penny. It was 3 seconds, and I'll give you that equation too. So T softening, we're looking at 50 degrees Celsius. So the air temperature, let's just say, T air equals 20 degrees Celsius. So the question is, how much energy? So here we are, we're going to be at the Maid Fair on Sunday. We're going to have a giant ball of LDPE. Some of it we're going to take over to be repurposed as packing material. Some of it will go into a waste stream, either building or burning. I'm not a big fan of burying plastic. I've had discussions with other folks who say, well, that's the only thing you can do with it. But frankly, I think if it's treated properly, you can burn it, turn it into energy product, and you can build with it. So how much energy to melt this plastic? And let's just say we've got 100 kilograms of it, of H or LDPE. So pretty simple. We've got all the numbers we need. We've got E equals C sub P M delta T. For plastic, so E 100 kilograms LDPE. Sorry, the writing got kind of small. Equals. Again, that says energy for 100 kilograms of LDPE, low density polyethylene, equals 2,300 joules per kilogram per Kelvin. And then the mass, I said, is 100 kilograms. and the delta T is 30. It's 30K or 30C, same difference. Run that, so 2,300 times 100 times 30. So we're looking at 6.9 megajoules. Is that a lot? Well, if you were to try to do that pedaling a bicycle, it would take you about 24 hours to melt that much low-density polyethylene, because one human daily metabolic unit is about 10 megajoules. So, there you go. From there, I might ask you to convert that to kilowatt hours. Let's say you're going to melt it with an electric heater. See how much that costs. If I gave you a dime per kilowatt hour, what's your energy bill going to be for melting that? Or if I say, hey, I want to melt that with the solar forge, how long do you have to stick that sucker in the sunshine to melt it? So a couple different ways of looking at it. One's going to cost you money, one's going to cost you time. And as we know, that's what it all comes down to. Okay, any questions at all? I think I'm gonna wrap it up here, unless there's anything else. I'll check the last few forums. And I think I've got, I think I got all of the lectures posted to date. I will post the 2 lectures from today as well, of course. Not a whole lot else kicking around in the forums there. Nope.
Do you have a how much is too much information for the summary?
Oh, for your paper, how much is too much? If you find you're just, I don't mind being a little long-winded. If you want to be long-winded in the background, if you've got a whole lot of methods, that's fine. If you've got a bunch of repetitive data or something like that, make an appendix. Yeah. Or if you've got just a lot of other pictures that maybe don't belong in the body, you can make as many appendices as you want, and you can just stick those in after the references section. Yeah. But yeah, if you're hitting more than 20 pages, I'll read it. I won't necessarily read every word, but I won't be overly impressed. I'll say, way to go, awesome. And it could be though, if you were looking to get your work published in a trade journal or something, that that you could think towards that, and look up to see what their publication requirements are, and maybe go that route. So if you go longer, say the reason I'm going longer is that's what's required for an external journal. Yeah. Okay. Well, guys and gals, thanks for a great semester. This is the first time I've taught this course, and I had a lot of fun. I know we did some hands-on. We did some theory. We did some paper writing. I think we looked into some of the politics on this. Looked into some of the challenges that Missoula faces. Also looked to see how difficult it is to break into the international market. I know a lot of people emailed seeing if they could become their own local distributors, and I think we're all realize we're just one little gear in the machine, or one little cog on the gears. So anyway, I really enjoyed it, and I look forward to seeing as many of you as possible from Made Fair on Sunday. We'll take some pictures and maybe even post them to the website and let you know how it goes. I think a lot of the climate change folks are going to be there with clipboards, kind of asking opinions, taking data on the views, people's views of recycling in Missoula, and if it looks like a lot of people would like to see more of it, that will encourage our local waste management companies do it. I just heard from Buttercup that Allied is, at least for their shop, stepping up to the plate. I hope that the Allied is actually making money on the back end, or Republic's making money by selling the commodities at some of the prices we've looked at, 10, 20, 80 cents a pound. So keep in and out of the landfills. All right, anything else before we go? Hit the bullpen? Okay, thanks. And good luck on finals, and look forward to reading your papers.